Okay, here is another example. Here this is in sine. V s of t is in sine. Okay, so you can keep it sine. You don't have to change it to cosine if you want. If you don't want to change it to cosine, that's fine. Okay, so we can keep it sine, same because you have only one source. So in this case, the Vs of t is just or in phase it is just 20 and 30 degree. You can lose it like this, 30 degree. So this is Vs. But keep in mind that it is in sine, not cosine. Okay. For the inductor, it is J omega what? J omega L. Omega is 10. So 10 times L, 10 times 0.2 is 2. So it is J2. So you can say this is J, thus J2. Then, of course, in this case, you have the total impedance is 4 plus J2. So this is the total impedance. Then you can convert this to real and imaginary using the calculator. So it will be here 4 square plus 2 square equal, and you add this, or you get a power of to the power of 0.5, which is the square root. Okay, 4.472. And the angle is 10 minus 1, 2 divided by 4. So 2 divided by 4, which is half, of course. Inverse 10 equal 26.565. So this is the impedance. If you want to find the current, so it is the Vs 20 and 30 divided by the impedance. So you divide the amplitudes 20 divided by 4.472. Okay, so this is the amplitude, and the phase 30 minus 26.565. It's 3.435. Okay, so this is I. If you want to convert it back to time domain, so the amplitude is the same, 4.472. Here it is, sine omega t, which is 10t, plus the angle 3.435. Then if you want to calculate the voltage, V is VL here. So VL, this is VL, because it is written here. This is V. Okay, this is VL. So voltage across the inductor. So it is I current time the impedance of the inductor. I is given. This is I. We have this I already now. Okay, you multiply by what? By the impedance, which is J2. J2 is actually, it is amplitude 2 and the angle is 90. When you have J, then it is 90 degree. So the amplitude is 2, the angle is 90 degree. Then what you need to do is just to multiply the amplitudes. 4.472 times 2 will be 8.944, and you add the phases. 3.435 plus 90 will be 93.435 degree. Okay, so if you want to convert this back to time domain, then it will be the amplitude here. There it is, sine omega t, which is 10, and the amplitude, the phase is here. Okay, so as you see here, we can keep the angle. If it is sine, you can keep it sine. You don't have to convert it to cosine. Okay, because once at the end I want to know what's the V of t. If it is sine or cosine, doesn't matter. Here, look at this example, and I want to find the total impedance. So here, actually, we are practicing what? Parallel and series, like in resistors when you have parallel and series. So we have to convert this to impedances, and if you have parallel, you multiply, divide by summation, and so on. So actually, this one here is what? Omega is 50. We need omega. So this one is J omega L. J omega L. 50 divided times 0.2 is 10. 50 times 0.2 is 10. So actually, this is J10. And this one is what here? 1 over J omega C. 1 over J omega C. 1 over J omega is 50. Okay, times C. C is 10 millifarad. So, C 10 millifarad. Say 10, and you add 1000 in the top, or 10 to the power of 3 in the top. Okay, like this. So it will be 1000 divided by 500, which is 2. So it will be 1 over, or 2 over j, which is negative j, negative j2. So this will be negative j2, negative j2. 1000 over 500 is 2, and 1 over j is negative j. Okay, so now you can calculate the impedance here. So it is 3 minus g2. This is z2. Z2, 3 minus G2. And this one here, this 3 is what? This 3 is this 8 ohm plus J10. So this is Z3. Where is this 3? This 3, yes, 8 plus J10. There it is. And the Z1 is this impedance here. Okay, what is this impedance? It is 1 over J omega C. There it is. We have it here already. 1 over J omega C. Omega is 50. Okay. And C here is 2 milli, so it is 0.002. You can make it like this. 50 times this will be 0.01. 0.01. Okay, so 1 over 0.01 will be 10. Okay, or is this 0.01? No, it is actually supposed to be what here? Supposed to be 100. 100, yeah. So it's supposed to be 0.1. So this would be 0.1. J 0.1. So 1 over 0.1 is 10, and j, you move it from the denominator to the numerator, will be negative j. So it will be negative j. So here, this is z1 is negative j10, and z2 is 3 minus j2, and z3 is 8 plus j10. Right away, when you deal with impedances, you need to convert them to amplitude and phase, because usually you need to multiply or divide. So when you do that, it is better to have amplitude and phase, because the multiplication and division is very easy in Phasor representation, amplitude and phase. So here 3 and minus G2, you can convert it as square root of 3. 3 square plus 2 square and the square root will be 3.606. And the phase will be negative 33.69. If you want to prove this, so first this Z1 is nothing but 10. You can make it like this, 10 and negative 90 degree. You can leave it like this. But for the for Z2, 3 square is 9, of course, plus 2 square is 4. Under square root, then you can say to the power of 0.5 equal 3.6. There it is, 3.6. And the angle here is negative 2. There is the angle negative 2 divided by 3. There it is. Inverse tan equal negative 33.69. So this is the angle. For this 3, it is 8. So 8 square plus 10 square, which is 100. Okay. And this to the power of 0.5. This will give you the amplitude, which is 12.8. See? And then the phase is 10 divided by 8, the imaginary divided by the real, and inverse 10, it is 51.34. So we have all the impedance now in amplitude and phases, and real and imaginary also. Okay, when you look at the new circuit, Z2 and Z3 are parallel to each other. Then in this case, you can simply say, okay, this is Z2 times the multiplication, or the resultant here is Z2 times Z3 divided by Z2 plus Z3, because they are parallel. So this multiplication over the summation. Okay, so you multiply. When you multiply, you use the phasors. When you divide, when you add, you use the real and imaginary. So here you multiply the two functions. Where is the mouse? Here it is. Okay, so you multiply them. Let's multiply. So you multiply 3.606 is this is amplitude times the amplitude of the other of these three, which is 12.806. That is 46.178. Okay, so this is the multiplication, and the phase is, you have 33.69 negative plus 51.34 equal 17.65. So this is the denominator. This is a numerator here, the multiplication. This is the multiplication. And you divide it by what? By the summation. When you add in real and imaginary. You do not add in amplitude and phase. So you add here 3 plus 8 is 11, and negative 2 plus 10 is 8. Okay, so you add in real x plus gy. And you then, to divide, of course, you need to convert 11 plus j8 to imaginary, to amplitude and phase. Otherwise, it will be hard for you to do it. So 11 square plus 8 square equal, and this to the power of 0.5. So this equals 13.6. So the amplitude is 13.6. And the phase is what? Is 8 divided by 11, okay, equal, and the inverse 10 equal 3. Is this right? I don't know. It doesn't look right. Okay, 8. No, of course it's not right. 8 divided by 11 equal, and this is inverse 10, 36. Yes, 36.03. So this is a 11.8, 11 plus j8 in amplitude and phase. Here it is. This one here. Okay. Now when you divide the amplitudes. So the amplitude here is 46 divided by 13.6. There it is, 3.395. And you subtract the phases, 17.65 minus 36.03. This will be negative 18.38. Okay. At the end, you can convert this back to real plus imaginary, and you need to do that. Why? Because when I merge Z2 and Z3, I have to add it to Z1. When I add it to Z1, then in this case I need real and imaginary. So you have to, how do you convert this to real and imaginary? It is 3 point or negative, was this 18.3538 negative. It is cosine and multiplied by the amplitude, which is 3.395. There it is. So this is the real 3.22. Okay, it is what? It is 3.395 cosine the angle. And then you do the same but sine the angle. So it is 18.38 minus, and this is sine. You see, sine negative is negative. Multiplied by what? Multiplied by the amplitude, which is 3.395 equal negative 1.07. So this is the real and imaginary. Then what you need to do now is to add this one to what? To the Z1, which is negative J10. So all what you have to do is just add a negative J10 to the imaginary here. So the real will be the same, will not change. The amplitude, the imaginary, you add 10, will be 11.06, like this. So this is the total input impedance for this circuit.